So Dr. Schwarz is professor of biochemistry at the College of Osteopathic Medicine and is the director of the Metabolic Research Center at Touro University, California. He's also an adjunct professor of medicine at University of California, San Francisco. He's led NIH-funded translational research focusing primarily on the metabolism of fructose, glucose, and lipids as key contributors to the development of chronic diseases. His talk is titled MRI and Spectroscopy for Fructose's Impact on Liver, Pancreatic, and Visceral Fat. Let's welcome Dr. Schwarz.
Thank you for the introduction and the invitation. You just read my title. I guess we use, and I'm going to talk about something that I did in collaboration with Dr. Noworowski at UCSF. She's the radiologist who acquire all those MRI and MRS measure looking at the effect or assessing the effect of fructose on liver, pancreatic, and visceral fat. Fructose metabolism has been a long and sweet journey for me, and I have been always very interested in non-invasive approach to study human metabolism, and my initial training was on stable isotope tracer that allowed to track metabolic kinetic. And we got interested in MRS and MRI in 2008 because it would allow us to have a better sense of the effect of fructose on liver fat, visceral fat, and I'll mention a little bit of intramuscular fat and pancreatic fat as well. And my initial work on fructose was focusing on the benefit of fructose. And fructose doesn't require insulin to be metabolized, and that was a big hype in the late 80s, early 90s. But at the same time, there was some work that suggests some negative effect of fructose on triglyceride level. And Sheldon Reiser and Judith Alfrich highlight that effect that was very different than glucose. Glucose doesn't seem to increase triglyceride in the same way. And they actually proposed that fructose was stimulating hepatic fat synthesis or de novo lipogenesis, DNL. You're going to see a lot of that in the next slides. They used mice actually to do this hypothesis and to confirm it. Their research was starting to highlight the potential negative effect of fructose intake on metabolic risk like cardiovascular disease and insulin resistance. So when in the early 90s, measuring DNL requires some invasive liver biopsy, which were not practical for human studies. So I became very intrigued when a non-invasive stable isotope tracer method was developed in UC Berkeley by Mark Ellerstein and Rich Nees. And that attracted me to join the lab as a postdoc and to learn that methodology that's really opened up a lot of options to do non-invasive measure of metabolism in human. And the initial study was to compare the effect of fructose to glucose on liver synthesis, that de novo lipogenesis I mentioned before, and to show also that fructose has a greater capacity to stimulate hepatic DNL. And that was a strong link to the increase of triglyceride level that are associated with fructose consumption. So that methodology, just in a very simple graphic ways, basically you put some tag into the sugar, some carbon 13, and you can actually look at those carbon-13 into the fat that come out of the liver in the VLDL triglyceride. And you can either use the tag and put the tag in the fructose molecule, a 13C here, or another way to do it is to do a precursor, to use a precursor of de novo lipogenesis acetate to measure that flux into the production of fat palmitates that's attached to the triglyceride. And that method was named mass isotopomer distribution analysis, or MIDA. And basically, it used mass spectrometry to look at the distribution of single or no label palmitate, or single label palmitate, or double label or triple label palmitate. And from that distribution, you can actually calculate with some statistical help the de novo lipogenesis, that pathway that was not possible to do in a non-invasive way before. And that's the early work we did, that's reviewed in that paper, where we gave some lemonade, no need of teeth for that drink, fructose lemonade, and then they come back for glucose lemonade and the same subject. And you can see that de novo lipogenesis is very stimulated by fructose and not by glucose. So we kind of confirm some early animal work, and that really triggers some question about that pathway. And this is basically happening in the liver, and it's exported as VLDL triglyceride in the blood. And that's from a blood sample where we isolate the triglyceride-rich lipoprotein to quantify this fractional DNL, which is the percentage of triglyceride that comes from carbohydrate, that fructose label, or that acetate labeling that pathway. So does fructose raise liver fat through DNL? That was the next question, and that's when I approached Dr. Novorosky at UCSF, and she used MRI to study fructose impact on ectopic fat. The research focused on how hepatic DNL can maybe be involved in that liver fat and visceral fat potential. I mean, the question was this fructose DNL also impacting those fat deposit, ectopic fat? We also look, and she looked also at the pancreatic fat and intramuscular fat. We'll come that, and she will intervene. She's on the talk, and she will intervene when I need help, because I'm definitely not a radiologist who can tell you the detail of how this is done. But if I try, I would say that you first try to locate the liver. For example, in this initial study, we use a voxel. So it's a little box of the liver in which we can place that voxel in a place where we have just liver and not vessel and stuff like that can interfere. And with the magnetic resonance spectroscopy, you can actually have a peak of water and a peak of lipid that's identified. And by measuring this, you can calculate a fat fraction, which is the lipid divided by the lipid plus water. And that gives you a percentage of fat, basically, that you have in your liver, and you can look at change. You can also choose some other MRI of the pancreas that you can locate there, and the visceral fat, you can do also that by doing some section. And by doing this, you can assess ectopic fat in different tissue, which was the question we wanted to ask. And we wanted to ask because there was emerging data showing really a clear connection of insulin resistant in the periphery, like in the skeletal muscle that was associated with visceral fat, and some hepatic insulin resistance with the liver fat, and also some impaired beta cell function with pancreatic fat. And all that was also associated with often some inflammation. And so that was definitely a really interesting hot topic. In that slide, it's mentioned implication of overfeeding. What we will show you in the next slides is that you don't need to overfeed people to have some of those change of fat deposit. You just need fructose. It's a sweet story. And does fructose-induced hepatic DNL lead to liver fat accumulation in healthy not overfed people? So that's the first study we did with this MRI, and it was an inpatient study that actually required 18 days of hospitalization where we could control the diet and also control and make sure that they were in energy balance. So we didn't want to overfeed them. We kind of measure that by indirect calorimetry also to calculate their energy needs. And we basically studied 8 subjects. 4 started with a complex carbohydrate diet with very little fructose, the minimum fructose you can give in a diet. And another one where 25% of the energy intake was coming from fructose. And in another set of subjects, they started with a high fructose, and then we went to the complex carbohydrate diet. So that's the diet composition. As you can see, about 4% of fructose in the complex carbohydrate diet, the same carbohydrate content, same protein content, and fat content. But we have half of the carbohydrate as fructose in that high fructose diet. So this is the weight variation over the 18 days or 17 days recording of the weight there. And you can see it's stable, and we really match their energy needs to avoid any overfeeding effect that was claimed to be the reason why fructose creates some problem. So
I just want to let you know you have 2 minutes.
Oh, 2 minutes? Okay, so fractional DNL was increased as expected. You see every subject increased DNL or decreased when they started with the fructose. And so we did those. This is a dramatic change in liver fat in 1 week. And basically you can see it goes down, the peak of lipid goes down with a high fructose complex, was followed by the complex carbohydrate diet. And Dr. Novorosky, here we have about a 20 overall for the 4 subject going that way, 25% increase, even more than 30% decrease when you start with the fructose diet. So that's basically somehow confirmed that this DNL was correlated with the liver fat intake in only 9 or 8 days, actually. And we saw some hepatic glucose production, dysregulation, sign of hepatic insulin resistance. So that was one study. The next study was a fructose restriction, and we studied some Latino and African-American children where they had an habitual high dietary intake, and basically they went for 10 days on a low fructose diet, not a particularly healthy diet, but just no fructose at all. And that fructose restriction we measure at the beginning on their habitual diet and at 10 days. And we did similar measurement, and as you can see, there were kids with a median age of 13, and we can see the lipogenesis again much lower after the 10 days of fructose restriction, and the liver fat also tremendous decrease of liver fat. A lot of those kids had some liver fat to start with, and this is the 40 or 30, not 38 or 39 who went through the diet, and you can see that the DNL seems to go almost systematically down, as well as the liver fat, except a few things, and that's the mass spectrometry, other mass magnetic resonance spectroscopy that show that. So we did also this is the liver, and you can see the visceral fat went down, the pancreatic fat went down, the insulin kinetic was also improved after that fructose restriction, and we measure also intramuscular fat, which I'm not going to get into that, but you can actually with MRS detect extra intramuscular fat, and that's or lipid, and that's it was diminishing as well. So the same story, hepatic DNL go down, liver fat go down. This was an energy balance also, although a few of the kids lost weight because of that. And this is my colleagues. I really want to thank Sue for great work on the study, and my colleague at Touro. And we did also similar study at UC Davis with the use of CT scan to assess visceral fat, and that confirmed the thing. So here you go. This is the Touro Metabolic Research Center in California, and you can see we have a big parking lot. So if Dr. Keel wants to come with his MR, mobile magnetic booth, is very welcome. We are very interested in that.